Good morning. This is Unit 6, Day 5 notes. We're going to go over binomial distribution today and a little bit of normal distribution. So, a binomial experiment is characterized by a repetition of a number of independent trials. This is also called the Bernoulli trials. Two successful outcomes, or success if it occurs, or failure when the event does not occur. Probability of a success is a constant for all trials. We're going to let Q represent the probability of failure. Then Q is 1 minus the successes, or P. P is the successes, or the probability of a success. A discrete random variable is going to be X, which is a total number of successes in an amount of trials. And I know this is a lot of wording. We're going to go over an example right now. An illustration binomial probability distribution. So this is actually going to be using the binomial theorem. Suppose a spinner has 3 blue edges. So it has 3 blue and it has 1 white. For each spin, we will get either a blue or a white. The chance of getting a blue is 3 out of 4, and white is 1 out of 4. Consider twirling the spinner 3 times. If we call blue the success, and white is the failure, then we have this binomial experiment. The probability of success is the blue, which is 3 out of 4. And the probability of a failure or getting a white is 1 out of 4. And we want to roll it 3 times. So my n is going to be 3. So these are this is my tree diagram. And the probability of getting a blue each time is 3 out of 4. And we're not taking anything away, so each time we do this, it's going to be 3 out of 4. Okay? Each blue is going to be 3 out of 4. The probability of getting a white is 1 out of 4. Now, the probability of getting all white. Oh, it says to find the random variable. Well, X is going to be the number of blue spins. This is going to be my success. So getting all white, this is going to be a failure. So the probability of white, white, and white, because we're rolling it 3 times. Well, we're going to follow this. This is 1/4, 1/4, and we have to get 1/4 again. So the probability of getting white, white, white is 1/4 times 1/4 times 1/4. And this is 1 over 4 cubed, right? Multiplying it 3 times. The probability of getting 1 blue and 2 white can happen 3 different ways. We can get a blue, and then a white, and then a white. So that would be 3 over 4 times 1 over 4 times 1 over 4. But we could have gotten a white first, and then a blue, and then a white. So that would have been 1/4, 3/4, 1/4, which is the same thing. And we could have gotten a white first, which is 1/4, and then a white, and then a blue. But that is the same thing also. So what we can do is just multiply this by 3. I can condense this a little bit. This is 3 times 3 over 4 times, this is 1 over 4 squared. Interesting. This is kind of like the binomial theorem. Let's do the third one. So the probability of X equal 2 means we're going to have the probability of having 2 blues and 1 white. So we'd have 2 blues and 1 white. We could have done blue, white, white, or we could have blue, white, blue, or we could have a white first and then a blue and then blue. And I think that's the only 3 ways we have. Now, if we have a blue, that is 3 over 4. and then another blue, that's 3 over 4, and then a white, that is 1 over 4. And each time it's going to be the same. So this is also 1, 2, 3 different times. I'm just going to multiply it by 3. But do you guys see that this is also 3 times 3 over 4 squared now? 4 squared, and then 1 over 4. Remember, that's the binomial theorem. We take 1 away from this term. We take 1 away, and we give it to the second term. We take 1 away again, we give it to the second term. Okay, now let's find out what's the probability of getting all blues. So blue is 3 over 4. Blue is 3 over 4. Oh, and blue is 3 over 4. So this is 3 over 4 cubed. And let's look at these coefficients in front of the fractions. So there is no coefficient here, so that means it's a 1. The coefficient in front of this one is a 3. The coefficient in front of this one is also a 3. And then the coefficient in front of this one, there's nothing, so it's also a 1. I'm just going to rewrite it here, kind of condensed, show you what it looks like. 1 times 1 over 4 cubed, and then 3 times, and then 3 over 4 times 1 over 4 squared, and then 3 times 3 over 4. Remember, we add 1 to the second term, and then we take 1 away, 1 over 4, and then 1 times, and then we give all of the exponents to this term, so it's going to be 3 over 4 to the third power. And this is because there are 3 trials. Alrighty. So it says, what do these coefficients remind you of? They're talking about 1, 3, 3, 1. It says, in general, P of x equals x. The little x is the number of successes. In this case, it was blue. It is 3 choose x. 3 over 4 to the x, and 1 over 4 to the 3 minus x, or I think we use like n choose r or n choose k, a to the n minus k, and then b to the k. That's what we used. Same formula. It says, consider a binomial experiment for which n is the number of independent trials. P is the probability of success. Then 1 minus P, 1 minus probability of success, is the probability of failure. Then the probability that there are r successes and n minus r failures is given by P of x equals r, is a binomial probability distribution function. And it says P of x equals r equals, and choose r, P to the r, and 1 minus P, or the failures, to the n minus r. Now, I'm going to show you what these mean. So this is the probability of successes right here. The number of success. So keep this, it's very important. N choose R is how many ways P is a probability of success. S. Okay. And 1 minus P is the probability of failure. And N minus R, remember N is a number of, N minus R, this is the number of failures. This right here. Number of trials minus the success. All right, expect or mean outcome of the experiment is the mean is, or the expected value is N times P. That's it. So the number of trials times probability of success. If X is a random variable, this is my random variable, okay? Random variable. Of the binomial experiment with parameters N and P, then write X then NP. So this is distributed as. This little tilde right here is X is distributed as binomial and choose P. Binomial theorem. So binomial distribution, X is distributed as. Remember, N is a number of trials and P is a probability of success. Let's try an example. While training for the next annual Hunger Games, PETA shoots arrows at a target with 72% accuracy. He shoots 5 different targets. So the number of targets he hits is X. And X is distributed as then N equals 5, remember, and the probability of success is 0.72. Find the probability that he hits exactly 3 targets. So my formula, 3 targets is 5 choose 3, N is 5, so 5 choose 3. So 3 is R. 0.72 to the third power, and 1 minus 0.72 is my failure rate, and that I think is 0.28, and this is to the second power. Okay, and I'm just using my formula, N minus R. 5 minus 3 is 2. Okay, we would just put this in our calculator. I think it's about 0.293 is a probability that he gets 3 targets, or 29%. Find the probability that he hits at least 3 targets. So 3 targets or more. So 3, 4, or 5. Because he's shooting 5 different targets. That's why I'm going to go from 3 to 5. Alrighty, so the probability that my R's or my X is greater than or equal to 3 is the probability that we have X equals 3, and plus the probability of X equals 4, plus the probability that he gets all 5. And I'm just going to use a formula each time. I know that the probability that he gets 3 targets is 0.293. And the probability that he gets 4, I'm just going to use my formula. I know that's 5, choose 4, 0.72 is the success to the 4th power, and then 5 minus 4 is 1, so 0.28 is to the 1st power. Plus, the probability that he gets 5 is just 5 choose 5, which is 1, times, remember, 0.72 gets all of the powers, which is to the 5th power. Now, I would just use your calculator for these, add it to 0.293, and we get approximately 0.862. That's it. Alrighty, find the expected number of targets that he hits. Okay, so my expected number, or my mean, is, remember my formula is n times p. Okay, so there's 5 targets, and the probability, p is probability of success. My probability of success is, I think, 0.72, which is about, my mean is going to be, or my expected value is going to be about 3.6 targets. It's expected to hit. At least 3.6. Now I'm going to try to show you using the calculator. The first one we're going to do is going to be like A, and then the second one is going to be using B. So it says find the probability, this is how to find the probability of a discrete binomial random variable. It says there is a 5% chance. Remember that my probability is going to be, when we put this in for probability of success, this is going to be 0.05 or 0.05. 0.05. So there's a 5% chance that any apple in a crate will have a blemish. If a sample of 25 apples is taken, find the probability that exactly 2 of these will have a blemish. So we're only asked for 2. We're not adding anything up. So it's distributed as a binomial. Your n in this case is 25 apples, so n is 25. And your probability of success, or that it has a blemish, is equal to 0.05, okay? And we can use our formula. The probability that there's going to be 2, x equals 2, is 25, choose 2, and choose R. 0.05 to the R, and then to the 2 to the second power, and then I guess the opposite of this would be, or 1 minus this would be 0.95, that it won't have a blemish, to the 25 minus 2 is 23rd power. Okay, I think this is approximately 0.231. Now, in order to use a calculator, this is what we're going to do. You guys are going to go to second vars, and we're going to go to the one that says binomial PDF, the one that says PDF, not C. I think the other one says CDF, not that one, the one that says PDF. And you guys are just going to click on it. It asks you each one. So I'm going to just write it down so you have it. X equals 2, the binomial PDF. You're going to do 25 first. This is your n. This is how many samples we have, or the amount of trials that we're going to take. And comma, or you're going to go to the down arrow, right? I think it has a down arrow. And then you're going to put in the percentage of chance that we're going to have a blemish, which is 0.05. That's what you're going to put, comma, and then they want the probability that 2 will have a blemish, so 2. And then close your parentheses or press enter. And then it's going to copy and paste it into the regular screen. You're going to press enter again, and it's going to give you the percentage, which should be the exact same 0.2305, something like that. Alrighty. The probability of that is less than 3, so this time we're going to add it up. Less than 3, not inclusive, means that the probability of x is less than 3 is the probability that we're going to have x is less than or equal to 2. And this time we're going to add it up. So if we're trying to find the probability that x is less than or equal to something, This is when we're going to use the binomial CDF, when we're going to add up different trials. And this is still going to be N is for the number of trials, P is a probability, and X. But X is going to be different. Number of trials, probability of success, but X is going to be less than or equal to X successes. Okay, so this time we're going to go back to our second of ours, and then we're going to pick the one that says binomial CDF. And this one, we're going to binomial CDF. Still, my number of trials is 25, 0.05% chance, and it's going to be 2, but it's going to give us a different answer. So at least 3 means that we're going to have a approximately, I think, 0.873 for 87% chance. My expected value, remember, is the number of trials, which is 25, times my percentage of the blemish, which is about 1.25. 1 in every 25, or 1.25 in every 25 apples should have a blemish. All right, I want you guys to try this one. Properties of a binomial distribution. The mean is the expected value equals the number of trials times the probability of success. The standard deviation is, remember, it looks like that, the square root of the number of trials times the probability of success times the probability of failure. So remember, Q is the probability of failure. Maybe you want to put trials and success right here also. So on the next page, we're going to go over just the normal distribution, and this is what you have learned already in Algebra 2. When we have a discrete random variable, we can actually find the area under the curve because we're going to have like these rectangles. Remember, to find the area of it, it's just going to be base times height, or we're going to have this probability and this probability. But if we have a continuous random variable, it's in order to find the area under this curve between 2 and 3, we're going to have to use a calculator or calculus. That's what we're going to learn in calculus. So a discrete random variable, or maybe like a binomial random variable, which we have just learned, we're going to be able to find the probability between 2 and 3. The probability of x between 2 and 3, we can just find the probability that the binomial random variable is 2, and then add that to the probability that it is 3. And we learned how to do this. We'll just add them up. Now, to find the area under this curve, we're going to have to use calculus. We can't do that yet. For the normal distribution, many naturally occurring phenomenon have distributions which are normal and appropriately normal, or approximately normal, like the heights of adult males or the test scores. We use this a lot. The length of cilia on cells, described by the probability distribution function. We have this function. We have a family of bell-shaped curves. Remember, these are symmetric about the mean. And the symbol for mean is this. As x goes to infinity or negative infinity, to the right or to the left, we're going infinitely close to 0. So our function, our y values, go to 0. We do have a horizontal asymptote at y equals 0. It'll never go past the x-axis. I think they also want our function is less than 1, but always greater than 0 for all x. This is the integral from negative infinity to infinity of our function is equal to 1. So this integral symbol means this is like the area under the curve. The whole curve is always equal to 1. The probability always equals 1. So because 1 is the total probability. So they want us to say something like that. Oh, something right here. The total area under the curve is 1 because BC, this is the total probability. It's always equal to 1. My last one says most data closer to the mean. Most data is always closer to the mean rather than farther away from it. It's all about sigma. We're talking about standard deviation. Remember, we have to remember that empirical rule. This is something that they want us to know. The mean, this is a symbol for mean. The standard deviation, this is the symbol. Remember the empirical rule. So if this is our mean, this is 1 standard deviation away, 2 standard deviations away, 3 standard deviations away, and this is still 1 standard deviation away, but this is our mean plus the standard deviation instead of minus. And then obviously this is our mean plus 2 standard deviations. And then this one is our mean plus 3 standard deviations. The empirical rule is 68% is in between the first standard deviation to the right and to the left of the mean, 68, and then we have 95%, and then 99.7%. This is called the empirical rule. Many of you might know how to use your calculator to figure these out. Remember, this is symmetric, so this is also 34.13, 39, or 13.59, perfect. Alrighty, you guys can try this out. You can also use your calculator if you know how. You just want to go through this. Standard deviation, or this is also called like the Z distribution or Z-score. The standard distribution is a normal distribution with mean equal to 0 and the standard deviation of 1. So our mean is 0 and my standard deviation is 1. So we're going to go to the right. This is 0 plus 1, which is 1. 0 plus, or 1 plus 1 is 2. And this is going to be negative 1 and negative 2. Every normal distribution can be transformed to the standard normal distribution or Z distribution using this transformation, you know, the Z-score. That's your Z-score. So this is going to be your calculator cheat sheet. We can try these out in class. I want you to try them in your calculator. So it says, this is the normal distribution. Go ahead and plug this into your calculator. Remember, your mean is always 0, standard deviation is 1 unless it specifies. And if you're shading to the left, that's going to be when Z is less than or equal to a number. If you're shading to the right, that's going to be when Z is greater than or equal to another number like A. And if we have an interval, it's going to be something like a D when we have something on the left-hand bound and the right-hand bound. Okay. this is all I'm going to go over today. If you have any questions, please ask. Have a wonderful day, guys.